Hello, math people. All right, so I'm not going to be here today, Monday, but I will be back tomorrow. Um, so while I'm out, the goal is to move a little bit forward in our equations unit. So before we do anything, here are four warm-up problems that I'd like you to try on your own. So you can take a moment, pause the video so that you can see the problems and try to work them out on your own, and then unpause when you're ready, and we'll go through them quickly together. All right, so let's just go through one by one. It says use inverse operations to solve. Okay, so inverse of addition I know is subtraction, so to solve this I am subtracting 14 from both sides because I know that whatever I do to one side of the equation I have to do to the other to keep it balanced like a scale. And 14 minus 14 cancels out, leaves Q isolated by itself. And on this side, 25 minus 14 is 11. And so I have my solution. Q equals 11. I know that's a solution because if I take 11 and substitute it in for Q and go back and check, 11 plus 14 is 25. Moving on to the second one. All right, I know that I'm going to have to use subtraction. That's my inverse of addition. And I'm subtracting 2/3 because 2/3 minus 2/3 cancels out. All right, that leaves x isolated by itself. Now, I'm subtracting 2/3 from this side of the equation, but the problem is I need common denominators. So I'm going to work on the side here. I'm just going to multiply the first by 3, 27/30ths minus, and I'm going to turn this into 30ths as well, 20/30ths. And that's going to leave me with 7/30 as my final answer. And if I plugged that back in, I'd of course get back 7/30ths plus 2/3 is 9/10 if you wanted to check it out. All right, final two here. On number 3, my inverse operation is addition. It's the opposite of subtraction, and the addition cancels out the subtraction there, and that leaves m isolated by itself. Whatever you do to one side, do it to the other. So 1 2/10 plus 2.5 leaves me with 3 7/10. M equals 3 7/10. If I plug it back in to check, 3 7/10 minus 2.5 leaves me with 1 2/10. All right, last one. Inverse operation is addition. That cancels out the subtraction, isolates the variable by itself, and if I add 27 to this side, I end up with 19 plus 27, 46. And if I plug it back in to check, I know that 46 minus 27 is, in fact, 19. All right, so the goal of today's lesson is we're going to still solve one-step equations, but now we're going to be working with division and multiplication problems. So I guess the first thing to realize is if I have division, the inverse of division, in other words, what undoes division is multiplication. And on the other side, if I have multiplication, the inverse is division. Or in other words, what undoes multiplying something, if I want to undo that, I divide it. And we're going to apply that now to some simple one-step multiplication and division equations. Also, just before we go too far, remember, an equation is like a balance. We want to keep things the same on both sides. So if you do something to one side of the equation, you must do the same exact thing to the other side so that it stays balanced and so that we can actually solve for whatever variable we're solving for. And let's take a look at what that looks like with some equations. All right, first one. I'm going to give you the following. Solve w over 4 equals 12. All right, solve tells me that I'm looking for the one solution for the variable that makes the equation true. And I've got w divided by 4 equals 12. Okay, so I have division. The inverse of division is multiplication. So that means on this side of the equation, I'm going to undo the division by multiplying. I'm just going to rewrite so we can see it better. All right. Opposite of division is multiplication. Multiplication undoes division, and that cancels out, leaving me with w on this side. Whatever I do to one side, I do to the other. So if I multiply by 4 here, I'm going to multiply by 4 here. And 12 by 4 is 48. And that is the solution to this equation. How do I know? If I take 48 and plug it back into the original equation up here, 48 divided by 4 does equal 12. So that is the solution to the equation. All I did was I used inverse operations right here. The inverse of division is multiplication. Inverse operations undo each other, or as I'm saying, it cancels it out. And that's how I got w by itself. Let's try another one. This time we'll do, let's do a divided by 8 equals 6. All right, so I need to use inverse operations here. I am going to multiply by 8 because it's the inverse of division. And what does that do? It undoes, gets rid of. That leaves me with a by itself down here. And whatever I do to one side, I do to the other. 6 times 8 is 48. How do I know this is the true solution to the equation? Because if I were to plug this back in up here, 48 divided by 8 equals 6. So I know that that's the solution to the equation. We're going to do 3 more examples together, and then we'll be done, and you'll be doing some practice on your own. If you want, take a second to pause the video and try on your own, and unpause and see how you did. But the next equation I'm looking at is going to be something a little bit different. All right, this equation looks a little bit weird, but what I have here is just a unique way that sometimes people will write a fraction. This is 2/7 times x equals 6. I will admit this does not look like 2/7 times x, but that is one way that mathematicians write 2/7 times x. They condense it all, it's a little squished together, but this is the same thing. I'm going to rewrite it on the right side of the screen. This is the same thing as 2/7 times x equals 6. So these two equations mean the exact same thing. The left side of the screen, the right side of the screen, I think is a little easier for some people to see initially. But if you can pack away in your brain that this and this are the same thing, you'll be in better shape going forward. Anyways, the opposite of times 2/7 is divided by. So I know that my inverse operation is going to be division. But if you think for a moment, 2/7 divided by 2/7 is the same thing as multiply by the reciprocal. Remember, when we divide by a fraction, division by a fraction is really multiplying by the reciprocal. So over here, I can save myself some time, and instead of writing division and then doing, oh, divide by a fraction means multiply by the reciprocal, anytime you see a fraction that's being multiplied and you need to do the inverse operation, which is division, I would just jump right into that. So I would write times 7 over 2. Now let's think about what that's going to do here. 7 over 2 times 2 over 7 equals 14 over 14, or 1. So what does that leave over here? That leaves 1x, or just x, which is exactly what I want. I want x by itself, so I have x equals. All right, whatever I do to one side, I need to do the exact same thing to the other, so times 7 over 2. Remember, any whole number just is over 1, so that's going to be 6 times 7. I'm going to have 42 over 2, which is 21 over 1, which is 21. X is equivalent to 21, and if you plug that back in, 21 times 2 sevenths is 6. But let's go back through what we did here. 2 sevenths times x. The inverse is division, so I'm going to divide both sides by 2 sevenths. But, like I pointed out over here, when you divide by 2 sevenths, or any fraction, dividing by a fraction really means multiply by the reciprocal. So instead of writing division, I actually just jumped ahead and wrote multiply by the reciprocal because I knew that is what I was going to end up doing anyways. I multiplied by my fractions, I simplified, and I got x equals 21. All right, that was a mouthful. I know I said I was going to do 2 more examples, but let's just do 1 more and then give you some time to practice. So our final example together, at least for today, is going to be the following. Let's do solve. That's 5. That's a bad b, but 5b equals 65. Well, 5b means 5 times b, so I know that my inverse operation is going to be divide by 5, because inverse operations undo each other. So that's going to leave on the left side of the equation b, and on the right I need to do exactly what I did on the left, which is divide by 5. And 65 divided by 5 is 13. So I'm left with a solution of b equals 13. I know that's correct because if I take 13 and plug it back in up here, 5 times 13 is 65. Oof, okay, so I'm going to leave this at this point. Your goals in class today are to just practice and get a little bit better at this. You don't have to walk away feeling perfect or like you're an expert. If you need, go back and rewatch any part or parts of this video and use it as you go through your homework problems for tonight. So your homework is attached on my homework. It's if you open it up, it's worksheet 7.3 practice A. And I would like you, it already says this, but in case you didn't see, I want you to do numbers 1 through 15, just the odds. And I also want you to do numbers 17 and 18. And you gotta start forming a good habit. So what I want you to do for each and every one of these is show your work. Show me step by step just like I did in these other problems here. Show me inverse operations, circle your final answer, and if you get stuck on any of them, they are all in some way, shape, or form similar to a problem that I solved earlier in the video. So go back, use that to help you, use each other for help. If you finish all of these in class before time is up and you're looking for something to do, I will post some practice on freckle if you'd like to use that, or you are welcome to pick an old skill of anything really, or even if you'd like more practice on this, and you can go on IXL and practice that. So number one, work on your homework. Two, if you finish early and are looking for something to do, head to freckle. Or number three, um, IXL. I'll leave these two things up to you, whatever you want to do. Either way, I will see you hopefully on Tuesday, and until then, have a fantastic rest of your Monday. See ya.